I'm not going to try to wow the crowd today with some amazing Go stuff that we're doing here at DigitalOcean or some amazing Go stuff that I'm doing in my personal life. I'm going to talk about something that I feel that no one really talks about in a lot of programming contexts of beyond the cool, beyond being a hobbyist, beyond just saying, hey, I know another language, you have to go to work and you have to write software that ultimately works well enough so you can make money with it. So from that thought, I came up with this Go at Work talk. So, but it's not really Go at your work, it's Go at DigitalOcean. And the reason I put this disclaimer on it is because you can't, besides Google, really, or maybe Spotify, and there's a few other companies, a lot of companies don't have, hey, we're doing a lot of Go, and this is how we do it, and everybody coming in off the street knows this is how we do it. And just to take an example, Rails came out, almost 10 years ago, and I wrote Rails for a long time, among other things. And I can bring a Go or a Rails developer here to DigitalOcean, show them our code bases, and they're gonna reel a little bit. They're like, wow, you guys did that. But that's normal. But they're gonna know this is how you write Rails. But the most interesting thing is that Go, I don't feel, is to that level where you can bring a new Go developer in, sit them down at the desk and say, here's our code base, go make something amazing. So I'm going to talk about a little bit about Go at DigitalOcean and how we're doing it. So this is me. My normal disclaimer is you can follow me on Twitter. I'm pro-black. I like to curse. And yeah, that's about it. But I share cool things when I see them. So if you follow me, I probably will not follow you back because I'm trying to go down. But it's still entertaining to see people laugh at my jokes. But definitely follow DigitalOcean. If you don't know, we are cloud, and we're trying to appeal to individual developers like yourselves to come and use our stack to build whatever you need. We're really trying to empower you. And on the other side, we're actually trying to give you the information because we actually have a very, very, very large community site. Actually, the director of our community site is in the back of the room. And there's just so much great knowledge on there that even if you're not using our hardware and our network to deliver your solutions, you can at least get some good information from there. Enough shilling. And I only did that because they got me food. So, Go. Go is something that gets me very excited these days, and it's really weird that Go gets me excited. As far as languages go, it's kind of boring. Or maybe that's what it's nice about it. There's not a lot of frills. As a matter of fact, sometimes things you've done in other languages, whether you've gone further down a stack where you're like C, C++, or even Rust these days, you're not going to find these features in Go. And then also, if you go higher up the stack to your interpretive languages, or even your other weird languages like Haskell or Erlang, there's similar constructs, but Go is Go. This is my obligatory picture of a gopher. And now I'm going to get into my talk. The way that I structured this talk is it's more of a journey of writing code. It's kind of like The Love Below by Andre 3000. Has anyone ever listened to that album? Where, it goes. And all the songs individually are pretty good, but there's a story in there. And I'm gonna do this with a story. So the first thing I want to do is start out with the bane of all fledgling Go developers, and also the bane of more advanced Go developers on the mailing list. When someone new says, I'm gonna write a web server or a web service in Go. So what do? They're coming, and I'm just going to use this. I'm going to use Ruby as my example because a lot of people know Ruby these days. So they go find something that's comfortable for them. And a cool package that I think is interesting is this package called Martini. And what it is it allows you to easily create web services. And from here, even if you don't write Go, you can pretty much understand what it does. And really, what it's doing here is it's saying whenever you issue a GET request to the root path, it's going to return hello world. And the next to last line just runs the service. Pretty cool. But There's a problem with that. It's not the go away. And this is weird because I don't know I can't really tell you what the go away is, but this is not the go away. So let's move something that's a little bit closer to how Go would do it. So what I have here is actually a package called Negroni. And actually I think the guy who wrote Martini wrote Negroni. I think he got a lot of pushback from the community about how horrible this Martini thing was. So he wrote Negroni. And the neat thing here is that Negroni also gives you an easy way to create web services, but what it also does is it uses some familiar terms that you would find in the Go standard library. So like this handle func, and we're actually passing it a handler because you know the signature with the response writer and the request, and we're using fprintf to print to this writer, and we're doing hello world. And it's the same thing, but still, you don't need this. And that's something that a lot of new developers to Go do not realize, is that this Chrome is actually, it's nice, and it might give you a good feeling while you're writing it, but you know, you don't need this. Go actually provides everything you need outside of the box, or you install Go, you can actually create web services in not a lot of lines. So right here, you'll notice that my import statements don't have anything from GitHub or anything else. This is actually out of the standard library. And it actually almost looks just like the Negroni one. And you can actually compose your services with this handle func, and we're saying the root path again, and we return this handler, and it does hello world. I know I've had a typo in all my slides. It's not hello world, it's hello, comma world. But I digress. So whenever you approach your Go projects, there's been a lot of discussion out there, and I'll get to that in a second. But let's move further up the stack, because the point that I'm trying to make here is there's a happy medium, and now I'm actually introduced. So I've written 3 versions. I wrote a Martini version, a Negroni version. I wrote a standard library version, and then I'm using something called Gorilla Mux. And you don't need Gorilla Mux, but there's something cool sometimes that when you add these packages, if you can find a good reason why to add these packages, it actually works. So Gorilla Mux, and there's another package called Gorilla Pat, actually has a method where you can inspect your query path. So if you are creating /foo/bar with standard library, you can get that out of there. You can actually parse the query path and get that out of there because it's in the URL. But we're going to be doing this a lot, and these packages provide little convenience methods where they can actually pluck vars out of the query path. And you know, that's neat. But the cool thing is that this doesn't look very much different from this. And because inside of the standard library, the Go developers actually introduce this concept of a mux. You could actually take this mux router and you can combine it with something else on a standard library later on. And actually with Negroni, you can do the same thing. You could actually just jam it all in there, use Negroni where it's useful, and where it's not useful, and you don't need all the extra Chrome, you can just use what's built in. So a couple months ago, out in France, this is Blake Mizrahi. It's funny is because the Martini, that little syntax, this guy created Sinatra, which is where that syntax came from. So it's funny now that Blake Mizrahi, I mean, he's definitely an esteemed Go developer now, says these things. And it says, you wouldn't go around picking stuff off the internet and street and eating it. So why would you do that with your dependencies? And I don't really have a great rebuttal to that, but I always want to say that it's always reasonable, and until Blake comes and writes code for me, we will do what's reasonable for our team. So how do you figure out the balance between what's provided in the standard library and your fancy stuff? Well, I don't know. But what you should always think about, because this is nothing concrete, is that whenever most of your application's logic is external to your application, that's no longer your application. And what you're doing by taking their software is taking on all the decisions they made, all the tests they didn't decide to write, all of that stuff, and now you have to carry it on your shoulders. So, but also remember that there's good stuff out there. No one in here is writing a MySQL driver. You're going to go use one. No one in here, I mean, there's a lot of, like, if you're doing CLI tools and you're doing anything more complex than just pulling off flags, why don't you use CodeGangsta's CLI? It works, it's functional. So yes, there is a happy medium, and you should find it. And we are working on finding it here at DigitalOcean. We actually had the great dependency snafu of 2014 just a little while ago, and we're getting better. So that brings me into the next subject, and I'm segueing to my next song now on the Love Below. So once you have your dependencies, there's always a discussion. So who here does not write Go? Okay, so let me explain to you how Go works. Go actually does not, so Go has a directory for external dependencies, and there's something called a GOPATH. And under your GOPATH, there's a directory called SRC. And what it does is it actually puts your dependencies inside of that directory based on the URL where they came from. So you would have a github.com directory, and then under there you would have /codegangster/CLI. And it actually just downloads the code using Git, Mercurial, or whatever else they use, but it actually knows how to download its dependencies. And so what some companies do, or actually, this is true, I wanted to say this first, there's a whole bunch of ways to manage your Go paths. And I think the Go developers, the core team, actually made a good idea. They did not actually say, this is how you manage your Go path, because Google is 25,000 developers. That's a lot of developers. And even DigitalOcean, I think we're about 40 people who would write Go, but actually it's a lot, probably half of that who possibly write Go, and it's probably half of that who do write Go. So 10 people versus, I don't know, many thousands of people. Can you really manage those in the same way? Sure you can, but there's going to be benefits for the larger group on one side, and there might be benefits for the smaller group on the other side that would actually hurt the larger group. So there's more than one way to do it. And because there's more than one way to do it, the internet has definitely risen to hate and throw a whole bunch of ways out there that, may or may not be correct. So I'll talk about the ways that we can manage our Go path. So there's a single Go path. And really, your Go path is set up like your Unix path. So you just put directory in there, put a colon, put another directory in there, and put a colon. Go will happily search all those. So for a long time here at DigitalOcean, we used a single Go path. And what we did is we put our all our dependencies. We actually developed our code in our Go path, and then we had another way of getting our vendored stuff in. So we call it vendored, our external dependencies. I've seen other companies, and actually at the GopherCon that was in Denver earlier this year, some companies actually do a Go path for each project. So they say that project X, that's over here. It should not touch anything else. Project Y, even though it uses some of the dependencies of project X, that's separate, totally separate directory. And that works because it keeps each one separate, and it allows you to make sure that your versions and all that are correct. Some people use a dependency manager. There's something called CodeP. There's GVP, or is it GVM, and then GVP is the other part. And what they do is they actually change your path in real time, and they store things below, so you don't have to see where your dependencies are. But it's hard for 40 developers to come to a consensus about everything, and actually at our company, it's hard for 10 developers to come to a consensus about everything. So we never actually chose a dependency manager. So let me tell you how DigitalOcean does Go. We have a single Go path now, and then we have something called a Doge. This came up because I guess Doge was a funny meme on the internet. I missed that part of the internet. That's not on my part of the internet. But there's this dog, and I think there's Dogecoin, and it had this dog. So one day someone says, let's have a DigitalOcean Go environment. I mean, we have a Doge, we have something called Adobe, we have all sorts of things. We're really, actually in our office, I think there's a sign that says go do it, and D-O is in capital letters. We're really about to do here. So we have a Doge, and Doge is like, well actually it isn't like, it definitely is our standard library. So we have Go standard library, then we have DigitalOcean standard library called the Doge, and then you have all your particular other apps that we do with Go, and it all just rolls up. So what we used to do is we'd have these vendor repos. So we use GitHub Enterprise internally. So we had a /DigitalOcean, we have a DigitalOcean repo or owner, and then we had a vendor owner, and we would put all our external stuff in the vendor, and then we put all of our internal stuff under our DigitalOcean. And that was nice, but the problem is that whenever we did our imports, you have all this external stuff, so the bits.do.co/vendor, it's there all the time, and when you have a few dependencies, it's kind of weird seeing that. Oh, no. So what we do now is, and I think I might have a slide for this, or I might not. We actually have a mono repo. And what we do now, and this is actually closer to what Google does, is we actually, in our GitHub, we have something called Cthulhu. I didn't know what this was. I had to go look this word up the other day, and come to find out it's pretty scary, which is fitting because the stuff that we're doing in our software is pretty scary. It's not bad, it's just scary what we're doing. So we have this Cthulhu thing, and then under Cthulhu, we have two repos in there. Or we have two directories, two GOPATHs. We have one for our code and one for a third party. And through some scripting magic, we tie them all together. And the cool benefits of this are that everybody is using the same version of any dependency, not the dependency that happens to be on your machine right now. If you make a change inside of the repository and it might affect someone else, so if you change a dependency, everybody gets the benefit. But also, if you introduce new code that can be reused, you don't have to worry about across GitHub repos, oh, are you using this, are you using that? No, it's in your GitHub repo, so you can just use it. And whenever I fix this to be better, it should be better for everybody. But you know, the negative part is when I break this for myself, it breaks for everybody. We'll talk about that later too. So, here's another, let's see. So GoPhumped. GoPhumped is actually one of my favorite things in Go. I've been at companies where we've had not almost physical fist fights over how you format your software. I think I might have saw a headbutt one time, but never any fist fights, but definitely a headbutt. People saying it's two spaces, or no, it's one space between your curly parens and the rest of your code. Now that we have GoPhumped, who cares? You save it, and if your editor is configured to run GoPhumped at the time, it just formats it, and you never think about it again. Actually, it removes a lot of stress. So, since we have that luxury now, you know, developers are always going to find something to gripe about. So now we've actually digressed down to the point of how do you order your imports. And so with Go imports, Go imports is a tool that another core guy at Go wrote that actually organizes your imports, or actually if you use an import in your file and then you save it, it'll actually update your imports line. It'll actually rewrite the file up. That wasn't good enough for us. Now we have to have a specific ordering. So now, like I said before, we have our standard library, that's up top, and then a line, and then you have your Doge stuff, and then a line, and then you have like your internal, like your app stuff, and then a line, and then you have your external third-party dependencies. And you know, I'm thinking, I can barely remember, yeah, I don't even know Go that well. And so we actually did toil around on this, and actually here's a good example of this. So this is how Go imports will sort it. So like I said, all this right here, actually these first 5 lines are, no, actually 1, 2, 3 are standard library. This is our Doge, and this is what I was working on, and here's our external stuff. So this must have been from a file where I was doing DB stuff. So we didn't want that. We actually want this. And you know, we're developers, we're a little OCD sometimes. So, you know, this actually might hurt somebody's sensibilities. So we have to move to this. And so but my argument was, well, I'm not going to remember this. So the cool thing is that Go's already thought about this, and this is like the power of the people who write Go. Go actually has a lot of static analysis tools written by actually this guy right here. And you can actually use the formats that GoPump and GoFix and these other things. And what we did is we actually, I'm not going to show you the source for this because it's not ready yet for public consumption, is we actually wrote another Go import-like tool that actually formats your code like this. And the cool thing is that it knows about how we work. And I'm pointing at my screen like you guys can see it. It knows how we work. It knows we want these separated, and it automatically does this. So it actually removes the burden of thought from the developer because we have tools, and we use our tools to actually make us better. So the point that I'm making here is that we are using the power of Go to deliver software, but we're also using power of Go to change the way that we work on software. And that's pretty powerful. So the next thing I want to talk is about, so we're segueing again. We came in here, we're falling in love right now, we're on an upswing, and now we're at the top, so we're talking about testing, we're at the top now. So I'm going to talk about testing to Go. So I hope, who here does not write tests? And it's okay if you're not a developer. Who here is not a developer? All right, awesome. What do you do, my friend? Systems engineer. Yeah, you should write Go too. Okay, okay. Well, you're a developer, you write software, and you get paid for it. Okay. So you're writing tests, and this is actually just me. I'm actually kind of weird about testing. Many years ago, back in the dark ages of the internet, I actually kind of got internet famous by using the F word to talk about testing. For a long time, I think I could have went 25 minutes of just saying F this and F that about testing. It was kind of like a Marxist rant on why you should test. But you know, I'm older now, and I'm not going to do that today. So I want to talk about testing in Go. And the reason I want to bring this up is because testing in Go it's pretty amazing. If you come from Ruby land or you come from Python land, there's lots of testing. And actually, the reason that I bring up Ruby for this is because Ruby has actually changed the way that people think about testing. And things like RSpec and a lot of, actually Ruby has talked more about testing their code than running it in production. And I don't know if that says something about how hard it is to get Ruby in production or how much Ruby is like test, but either way, they talk about it a lot. So the cool thing about testing in Go is this. In the standard library, there are testing constructs. There is nothing to download, there is nothing to install. If you can't install Go, then that's another conversation. But once you get Go installed, the testing constructs are here. And this simple test is we're squaring a number, and we're just testing it. As a matter of fact, our Go core developers like the community so much, they actually have given us thoughts on how we should write our tests and how we should phrase things in our tests. And I'll actually share that with you after this. So this is actually my TDD example. TDD in static languages is really fun because the cool thing is you can actually write these tests, and if I save this and I run the test, what's going to happen? Anyone? Oh, I'll give you a hint. It's going to complain. There's nothing called square. There's nothing called square. Point at my desktop again. Because I'm writing I wrote the test first. There's nothing called square in this case. So look, undefined square. There we go, winning. So we create a square method. And the only reason our square function, the only reason we create it like this is because we're only trying to satisfy the error message that we got. And the error message that we got is that it's undefined. And so we just return 0 because that's actually pretty much the easiest thing to do. Let's not think about this yet. So now when we run our test, it says, hey, we expected 25, but we got 0. And we failed, which is cool because now Go is telling us, we don't even have to think about this anymore. Now Go is telling us what to do next. And actually any programming language will do this. So now we return 25 because guess what? It expected 25. So we return 25. Yes. But you know what? Testing is not about just testing at one time. Testing is about doing multiple examples. So let's see what happens when we square 0. So same test, different test method. And we return 25, but we expected 0. So now we can put the real logic in. And it's really simple in this case. This is x times x. So we test it. and that's fine. But inside of Go, and this is what I'm talking about how good our core team is, and I'm saying R because I'm talking about Go, they've actually illustrated another way to create test cases. And what I'm doing here is I'm creating a struct on the fly, and I'm just saying what the argument is and what it's expected, 525, 0, 0, negative 1, and 1. And then I'm just ranging over it using a little bit of simple Go, and then I'm testing it. And now I don't need a test square 5, test square 0, test square whatever. And this is actually not just Go specific, this is actually just language. It's just like a language thing. And thinking like this, and I just like talking about testing. One interesting thing is, I like talking about testing and I like to test, but I don't like running my tests. I will actually forget to run my test. So there's two things here. There's this tool called Looper, and I'll show you how this runs. Uh-oh. There was a video here. But what it does is Looper is running down here. Whenever it detects that I've saved something in my Vim, it just uses fs notify and it'll actually just run it for me. So my tests are running all the time. I don't have to think about it. Another tool is called Go Convey. And this one's a little bit different. They actually have a whole testing dependency. They want you to write tests in a Ruby-like way. I don't like that part. But what they do is they give you a web page, if you're into this kind of thing, and the web page, as you are running, as you are just writing your code, you don't have to think about it. You can just look at the web page, and that thing will go from pass to failure to other things. I kind of like it sometimes, but I never use it. I actually use Looper all the time. Oh, this one actually works. So real quick, because I took a lot of time to put this video together, you're going to have to see it. See, pass. See, fail. And you know, we're developers. Little things like this entertain us. And you know, you guys can watch my failures and it'll make you feel better about your development. So, it's hard. Sometimes I put links up, but this guy is Andrew Gurn. He's another guy with a great accent because he's Australian. And he's a Go core guy. And he's actually wrote these two tests, or these two talks. And I only put them up here so you can go Google them. But they're good. And I actually enjoyed the Go guys slides because they're always all the same. And you're going to see this in a second. They're going to be like the Go slides. But they're always, these are very easy to follow. And these two things are really good. So we figured out how we're going to write our code. We've written code. Now, what's next? Code reviews. You know, I only have 2 slides on this because this is how I feel about this. The first thing is, I want you to start here. I did put this URL in here, but it's on the Go wiki and code review comments. You can Google that. You probably just Google Golang wiki code review comments. It's actually a very constructive way of doing comments because the most important thing about reviews are why and not how. We're actually really bad as developers, and I'm sure everyone in here is guilty of this. Someone will submit some code and they want to review, and you'll just go, I don't like that. That sucks. Why would you do this? That's not that why, but why would you do this? Or they'll just go in there and they'll say, this is horrible. But you know what? You can say all those things, and you can actually put them at the bottom. You can say all those horrible things if you say why the code is bad and how you would fix it. But if you don't do that, then it's all moot. So, you know, code reviews. So we do code reviews here. Actually, I won't say 100% because some people like to sneak things in, but at least on our Go side, everything is reviewed by at least one person in some time. So now that we have our code reviews, and we're moving through the level below, we have continuous integration. And I found this on the internet. I just thought it was very funny. I don't, you know, I can write software, but I can't do this. And I don't even know what that has to do with continuous integration, but I did like it. So, continuous integration. We use drone. We have a cloud. We're not farming this piece off to another piece of software. So we use drone, and we actually saw this this is actually a project that was endorsed by Google in some way, and what drone is just a continuous integration that actually runs in Docker, or it runs all the tests in Docker. And is it better than Jenkins? I don't know, probably not. But it's cool, and it's easy to use, and it doesn't have a lot of buttons, which gets us pretty far. Another thing we do is after we run our things in continuous integration and they pass, we have an artifact server that we wrote in Go using the standard library, not Negroni or Martin or Martini or Gorilla. And what we do is we package it up and take the binaries, because Go binaries are easy to find, and we just copy those up, and that's how we publish. So this brings me to the last piece. So now that we've done all this, we went through all this progress, or all this process, how do we get it out? This is a good one for us, and I only have a couple slides on this one. We have little deploys. You know, I have this service, needs to run on 10 servers. That should not say unusable. That's the first typo of my slides. I typed in Ansible, and I got Apple corrected. So maybe Apple is saying something to me. That actually should say Ansible. Maybe that's a subtle hint, but no. Which is funny because we have an Ansible committer that works on our team, but we use Ansible. And the reason we use Ansible is funny because I'll tell you what we use another time. We use Ansible, and we have just Ansible pushes things out. It'll copy to 10 servers. It takes almost no time, and everybody can read Ansible configurations, and it works. And the cool thing about Go is whenever you package your binaries up, you get a binary. There's not some huge assembly. There's not this jar file. When you put it on the servers, you compiled it for Linux. This is why we're using Docker, is because we can actually control the version of software that we are actually compiling on. So whenever you get this little binary, or it's going to be a big binary, it's Go. So you're going to get this binary, you're going to put it on the server, and it's going to run. And the cool thing is that there's packages for Go that will actually, if you're making websites inside of a Go, you can use this thing called Go bin data, and you can actually put your data inside of a directory. When it's compiling, it'll actually generate a binary file of source, and whenever you compile it, it's still in there. So you can have assets, you can have all sorts of things in one binary. It's not like a Rails, or it's not like Python. It's just one file. You copy to the file, you make it executable. That's it. But here at DigitalOcean, we do have many, many thousands of servers. So sometimes you just can't use Ansible. We use Chef, and we use Chef to provision a lot of our things and manage a lot of our things and do orchestration for a lot of our things anyways. But it's harder. Writing a Chef cookbook versus doing a little Ansible file. It's funny. For little ones, it's a little bit of work with Ansible. For bigger ones, it's bigger work with Chef. But after you get it done, it's simple and it runs. And we've used Chef to deploy software on thousands of servers, and within an hour, it ends up there. So I want to leave you with one thing. I wouldn't say this about a lot of languages. I tried reading the source of Python, and I learned a lot about that. I tried to read the source for Ruby, and I wrote a lot about writing Ruby in C. If you actually look at it, it's actually Ruby in C. But Go is pretty readable from the top down. From reading the Go that people write, for the most part, you can read. The standard library is very readable, and it's kind of cool because a lot of patterns that you might find are probably going to be somewhere in the standard library, so you can just do some copy-paste coding. And it's cool because it's vetted, because it's in the standard library, so that works. But read the source, and DigitalOcean thanks you guys for coming out tonight, and that's it. Thank you. Any questions? Yes.
You mentioned the problem with upgrading your dependencies is that everybody feels that. Can you talk more about how you deal with?
Oh, so we moved all of our dependencies to one repo, and the reason why is because so Go doesn't really have versioning of dependencies. It just has dependencies. So I could download it 759 and I get one version. You know, developer pushes a new version. Someone does a go get or go install later, and they get all the other ones. We've actually killed that. Everybody is running the same copy no matter what it is, and it doesn't even matter what version it is as long as everybody's running the same copy. So that's what I was saying there, and that's why we have the mono repo.